This lesson is on exponential functions. So if you previously recalled, we looked at x as a base with a power, such as y equals x squared, or y equals x to the third minus 1. So an exponential function has the x in the exponent. So if we're going to graph our function here, we want to pick values of x. We're going to pick -1, 0, and 1. So we have 3 to the -1 for y. That's 1/3. 3 to the 0 is 1. 3 to 1 is 3. And I want you guys to know that all exponential functions have horizontal asymptotes. And I will abbreviate this HA. Okay, so all exponential functions have a horizontal asymptote. And we're going to put, just to remind us, which I've done before, we'll put HA. And it's the up or down shift, okay? So in our example, we have not added or subtracted a number. So here our HA is y equals 0. So I'm going to go and graph an HA here. Then I'm going to take those 3 points and graph them. -1, 1/3 is about right there. 0, 1, 1, 3. If you recall, we don't cross those asymptotes. We get close. Okay, and we try to hit our points. Okay, so I'm trying to skim along the asymptote there. Don't cross it. And so that's what an exponential function looks like. If you notice, ours is always increasing. Okay, so let's look at the next one. What happens when the exponent is negative? Again, choosing -1, 0, and 1 for x values. 2 to the -1. That's 2 to the 1. That's 2. 2 to the opposite of 0 is 2 to 0, which is 1. And 2 to the -1 is 1/2, which is 1/2. Again, notice I didn't shift it up or down. So your HA is y equals 0. And we're going to graph -1, 2, 0, 1, 1, 1/2. If you will notice, this function is decreasing. Okay, number 3, there's a number here, this 1. So my HA is y equals 1. Also notice the x plus 1. With the x, that means it's going to shift left 1. So the first thing I'm going to do is put on or graph the asymptote. Now, because it shifts 1 to the left, the -1, I'm going to do -2, -1, and 0. So where did -1 come from? If you take your x plus 1, set it to 0, you get x equal -1. That means we're going to shift left 1. So when I make a table, we want that to be the middle value. So you have 1 minus 2, -2 plus 1. So that's 1 minus 2 to the -1. That's 1 minus 1/2, so that's 1/2. Now let's do the same thing with the 0. This is 1 minus 2 to the -1 plus 1. 1 minus 2 to the 0. 1 minus 1 is 0. I'm going to go ahead and confirm these with my graphing calculator here in just a minute. And then let's plug in 0. 1 minus 2 to the 0 plus 1. That's 1 minus 2 to the 1. 1 minus 2 is -1. Okay, so if you go to y equals 1 minus 2, and there's underneath clear, there's an up button. So you do the parentheses x plus 1. When you use your graphing calculator, Make sure that x plus 1 is in parentheses. Okay, we will graph this. And I am looking at the double check. Negative 2, 1/2, negative 1, 0, 0, negative 1. So these are correct points. Negative 2, 1/2, negative 1, 0, and 0, negative 1. If you notice, this is now a decreasing function. The negative sign in front here, the subtraction, which is plus and negative, has flipped it over the x-axis. All right. Now, let's talk about our shifts. I have a review of shifts here. So the base is b. That has nothing to do with your shift. It does affect the graph. A here is a multiplication. So that should be pointing to the a, not to the f of x. If a is less than 0, it reflects across the x-axis. If the absolute value of a is between 0 and 1, it vertically shrinks. If the absolute value of a is greater than 1, it's a vertical stretch. And then the k value here is positive is up, negative is down. And then if you notice to the notes over here, I wrote x minus h shifts right. X plus h shifts to the left. It's opposite what we think. Okay, now the next two examples, well, actually 4, 5, and 6, have to be done with the graphing calculator. Okay, so it says round to 4 decimal places. So you do, to get this on the calculator, it's second ln. Okay, it looks like in, but it's ln because ln is natural log with the base e. And you do up 3. So I'm going to do second ln. Then up 3. Okay, it would help if I did the right number. That is a 2 there. So second ln. Okay, let me change that for us. Make sure I can read that. That's a 2. Okay. So we're going to do second ln 2. We're going to get 7.389056099. Okay, and we're going to round it to 4 decimal places. So if I count 1, 2, 3, 4, so the 5 here is going to tell us to round up. So it's a copy of the first 4, 7.3891. That's your final answer. So this is e to the negative 3, so we're going to do second ln negative 3 because the e shows up on your calculator. And I get 0.0497870,684. Okay, so we don't want that. It says round to 4 decimal places. 1, 2, 3, 4. Again, the 8 tells you to round that number next to it, the 7 up, 0.0498. Now, with e, because e is defined to be approximately 2.718, it's like pi. It has an approximation answer. It's a transcendental number because none of the values repeat. And it doesn't terminate. Okay. So because of that, we're going to use our calculator here. Again, we're going to do negative 1 and 0 and 1. So if I do second e to the x plus 1, again, mine's going to get shifted, so I'm going to have to change my values. I didn't see that. We go to y equals second e x plus 1. You go second graph, and we should do negative 2, negative 1, and 0 because I've shifted it. See the negative 1? So negative 2 is 2 decimal places, 0.371. This is 2.72. Okay, again, the HA, since there's no up or down shift, you don't have plus or minus number there, is y equals 0. We'll graph that first. Negative 2.37. See, negative 1, 1, 0, almost 3. So again, it's an exponential. It will grow like that. All right, now we want to look at money and investments of money. Okay, so P is the principal. It's money that you either have or that you've borrowed. And the R stands for the annual interest rate, and T is time in years. So simple interest is I equals PRT. That's not your total amount. That's how much interest you would earn. Then the amount after T years, compounding periods, like per month or per week or per day or per quarter, is A equals P, 1 plus R over N to the NT. And if it's compounded continuous, or continuous compounding, it's PERT. Now, before we do this, we need to talk about different values of N. So we're going to talk about the word and then what N can be. So if I say to you quarterly, so you want to think that quarterly is 4, so N would be 4. So if we have interest compounded quarterly, it's compounded 4 times a year. Okay, then there's weekly. So we think how many weeks are in a year? 52. Then there is monthly. So how many months are in a year? 12. Then we have daily. We're going to use 365. You also will see annually. Annually is once a year. Okay, so this is important when it's compounded different methods. So let's read number 7. Suppose $15,000 is invested with 2.5% interest under the following compounding options. Determine the amount at the end of 7 years. So for all of these, what we're interested in is P, R, and T. All of them will have a T. Now, quarterly was going to give us an N value, okay? So P is the money. So for P, that stands for principal, is 15,000. R is your rate, 2.5. So that's going to be 0.025 because it's 2.5 divided by 100. And then T over here says 7 years. Now, what's N? Well, what's quarterly? So if I know that quarterly is 4 times, we're going to put a 4 there. And our formula is A equals P times 1 plus R over N to the NT. So I think what I'm going to do is capitalize my R so it looks a little cleaner. So A is equal to 15,000 times 1 plus 0.025 divided by 4 to the 4 times 7. Now, it's really critical that 4 times 7 goes in parentheses. And A is the final amount. How much money will we have at the end of those 7 years? Or how much money would we owe if we're borrowing the money? Now, you might want to go ahead and say 4 times 7 is 28. And I get A is equal to 17,858.96. 17,858.96. Okay, in just a minute we will do compounded continuously. Okay, so I'm going to double check that one more time. 15,000. Okay, good. So we have that one right. So B is compounded continuously. Your formula is PE to the RT. So I'm going to work B down here. So A equals 15,000. And then we're going to use E to the 0.025 times 7. And I am sorry about the time sign. I just feel like we need to see that. So times 7. So 15,000 E, the 0.025 times 7. And you get A equals 17,868.69. And the compounded continuous should always give you the most money. Okay. So again, I need you to learn the numbers for n depending on the English word that we use. All right, so let's look at a word problem. Weapon-grade plutonium is composed of approximately 93% plutonium-239. The half-life of plutonium is 24,000 years. In a sample originally containing 0.5 kilograms, the amount left after t years is given by 0.5 parentheses 1/2 to the t divided by 24,000. Evaluate the function for the given value and interpret its meaning. Okay, so here, if you notice, it's a of t, so this is your t value. So this tells you t is 24,000. So a is equal to 0.5 times 1/2, 24,000, divided by 24,000. Okay, so that's 0.5 times 1/2 to the first power, so that is 0.25. So you'd have 0.25 kilograms. Okay, so it's this. After 24,000 years, there would be 0.25 kilograms of plutonium. Okay, 72,000. Here's T is 72,000. Again, so A of 72,000 is equal to 0.5, because that's the initial amount from right here. 1/2 to the 72,000 divided by 24,000. Now, I could go ahead and divide that out. So if we take 72,000, divide by 24,000, I believe we get 3. We do get 3. So that might be a little easier to type in 0.5 parentheses 1/2 to the third power. So that is equal to 0.0625 kilograms. So again, we'd say it this way. After 72,000 years, there would be 0.0625 kilograms remaining. Or we could say kilograms of plutonium. All right, so that's all we're going to talk about exponential functions. Have a great day.